Hi guys, welcome back to the channel. Welcome back to Mathematic Girls Swati 3226. This video is basically the second part of the video which I had already uploaded on the types of triangles. So in the last video, I had covered the types of the congruencies, and in this video, I'm going to cover the types of similarities. Okay. So if you have not watched that video yet, I'm going to put the link in the description box. Please watch that video and come to this video because first you should understand the congruent of triangles, and then you can watch this video. Of course, I'm not saying that you cannot understand this video without watching that video, but of course if you watch that video, you will have the confidence in the congruency of the triangles as well as the similarities of the triangles. So yes, um, please go and watch that video because then you will understand this video in much better way. So I have already discussed the congruency of the triangles. So when two triangles are said to be congruent, two triangles are said to be congruent if we have both the triangles exactly same shape, same size. All right. So we studied different types of congruencies in the last video. The first is side, which is all the sides are equal. And then we had studied side angle side, where angle is included between the two sides. Then we had studied angle side angle ASA, in which two angles are there and the side is included between the two angles. Talking about the second last one, that was angle side. So angle and any side. All right. And the last one was RHS, right angle hypotenuse side. I have made you understood the difference basically between RHS and SAS. So try not to get confused between those two. And if you have any confusion, please clear that with that video only, because in that video I have properly explained what's the difference between side angle side and RHS. All right, so moving ahead towards the similarities of the triangles. So let's understand when can we say two triangles are similar. So you can see here that this is a triangle, right? Can I not say that this is also a triangle? Of course, both of these are triangles, but you can see that this is a triangle. This is bigger in size, and this is a triangle which is smaller in size. So from that, we can conclude here that these two triangles are not congruent absolutely, because for congruency, it's very much important that both the triangles are of same shape and same size also. But here we can see that both are triangle only. Their shape is same, but their size are, their sizes are different. That is why, of course, it cannot be a congruent triangles. Now talking about what can be the relationship between these two triangles. So that is nothing but these two triangles are similar. All right. Now let's understand about the similarities of the triangles in details. All right. So for that, let me share the screen. And let me just give you a short, brief about what I had basically covered in my last video, where I had discussed about the congruencies and its types of the triangles, as you can see. So please go and watch this video. I'm going to put the link in the description box for sure. So yes, this is it. And talking about at the end, I have talked that, here triangle ABC is congruent to triangle PQR. We have a symbol for this, is congruent to. For that, we have a symbol, equal sign, and a curve. That's it. All right, let's move towards the similarities of the triangles. So yeah, let's write down the similarities. So today we are going to understand the similarities of the triangles and its types also. All right, so that's our video. If you want to give any suggestions, if you want to, if you want some other topic, some other class videos, please let me know in the comment section. All right, so that I'll be also aware that on what topics you want me to make the videos. All right, of course it should be related to maths only. I cannot make any other subject videos because I am here because I love this. That's the reason I'm here. So yes, let's discuss about the similarities of the triangles. As I said, here there are basically some conditions are there. First of all, same shape. That should be there, but not necessarily the same size as I showed you already, right? Same shape, but not same size. That's the first condition for the triangles to be similar. All right. Next is corresponding angles are equal. The corresponding angles have to be equal. For example, here, what do you mean by corresponding angles? For example, suppose I'm talking about this particular angle of this triangle, and I'm talking about, suppose, this particular triangle, this particular angle of this triangle. If the angle made by this triangle at this point and this point are equal, then we can say the corresponding angles are equal. Here in this case, the corresponding angles are equal, meaning this angle equals this angle equals this angle, and this angle equals this angle. That's the meaning of corresponding angles are equal. And the third condition is corresponding sides are in the same ratio. What do I mean when I'm saying corresponding sides are in the same ratio? That means, again, if I just, show you with this triangle, this side, okay, all right, this side and this triangle's this side. If I take the ratio, I hope you know the meaning of ratio. That means this side upon this side, this triangle, okay, this triangle. Then this side upon this side and this side upon this side. If their ratios are proportional, then we can say both the triangles are similar. That's the condition. All right. Now let's write down also something. I'm saying a lot of things. Now it's time to write down some of the things. So as I said, similarities of the triangles, we have three conditions. Just a moment. Let me write down that. All right. For that, let me draw two triangles, first of all, so that it will be very simple to understand. Because, whenever we do any question in maths, it's very important to draw the diagrams, because with the help of diagrams, almost, I can say 40% of the question is, already solved. So yeah, it's very important to understand the diagram. So you can see here two pictures, two triangles I have taken. Of course, they are triangles, but their size is not same, right? So let's give a name, ABC and PQR. So here I'm not talking about any types of similarities of the triangle. Here I'm just talking on the conditions for two triangles to be similar. So first, as I already said, same shape. All right, the shape, of course, should be same. It's not like one triangle and one square. We cannot say that both the triangles, both the shapes are, both the figures are similar. Of course, the shape should be same. So here, same shape, but not necessarily the same size. But not necessarily the same size. Here, when I'm using the word but not, sorry, I forgot the word not. Here, when I'm using this word but not necessarily the same size, I try to say here that it can have the same size as well. And if it, follows all the condition that all the, corresponding angles are equal, all the corresponding sides are in the same proportion, then we can say, even if they are having the same size, the triangles are similar, okay? But here I just mean to say, even if the sizes are not same, then also it can be similar. So yes, this was the first condition. Let's write down the second condition. And the second condition is, let me just increase the width. Yeah. So the second condition is corresponding angles are equal. I hope you have understood the meaning of corresponding angles. I'll make you understand here also. Corresponding angles are equal. Corresponding angles are equal. When I'm saying, I'm just saying that this angle, you can see here, y equals y, x equals this x. It's not necessarily, that if I'm taking this x, then this x should be here only. No. So this x, this z, and this z. We can see here that all the corresponding angles are equal. So that is why this is the second condition of similarity of the triangles. And now let's talk about the third, which is the corresponding sides should be in the same ratio. That's the third condition. Corresponding sides are in the same ratio. When I'm saying corresponding sides are in the same ratio, I just mean to say this. Here, AB, all right, AB upon, all right, I'm taking AB upon PQ equals BC upon QR equals AC upon PR. That should be the condition. I'm not saying AB equals PQ and then BC equals QR and then AC equals PR. No, I'm not saying that, because if that is the condition, then both the triangles will become congruent. Here, for the similarity, try to understand the difference between the corresponding sides are in the same ratio and the sides are equal. These are two different things, all right? So here the corresponding sides are in the same ratio. So these are basically the three conditions which, which is basically telling us that both the triangles are similar. Now let's understand what's the sign of the similarity of the triangles. So for that, let me first write down that triangle ABC is similar to triangle PQR, all right, is similar to triangle PQR. Now, what's the sign for this? What's the sign for is similar to? We have the sign is very simple sign. It's just a curvy line. That's it. That's the sign. So we can write down like this, that triangle ABC is similar to triangle PQR. That's it. All right. Now let's talk on the types of the similarities of the triangles. Okay, there are only 3 types of similarities of the triangles. Let's discuss that as well. So this is basically our types of similarities of the triangle. All right. Types of the similarities. So let's do one thing. Let's write down all the types first and then we will discuss it in detail. So there are 3 types of similarities, as I already said. The names are these. So the first one is angle, angle, angle. Do you know that even if we don't write angle, 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 we have another name for this? Or you can just write down angle, angle. Do you know why am I saying that angle, angle, angle or angle, angle? Because when we are having two, triangles similar on the basis of angle, angle, then of course the third angle is going to be equal to the third angle of the other triangle. There cannot be any other case, because suppose I'm just taking one case. Imagine that I'm having this as 60 and this as 40, all right, and this as 60 and this is 40. Do you know that from this only we can say that both the triangles are similar? Do you know why? Because here it's 60 60 40 40, so we can directly say here that the triangle ABC is similar to triangle PQR by which similarity? Angle angle similarity. You can say that no, angle angle similarity is not correct. We have angle 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 similarity, which is basically the same thing. It is pretty much obvious here that if this is 60, this is 40, this has to be 80 only. There is no other case, because we know that the sum of the sum of the angles of a triangle is 180 degrees. All right, so this is of course 80 degrees. So we got from angle, angle, we got angle, angle, angle as well. So here, if you are writing angle, angle, or if you are writing angle, 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 both are correct. So this was just for your understanding. I hope you understood what I meant to say here. And yeah, let's move to the second one. The second one is called side, side, side similarity. Very simple, very straightforward. Side, side, side meaning the ratio of this side upon this side. Okay, suppose I have two triangles. The ratio of this side upon this side upon this side, and this side upon this side are in the same proportion. Then we can say that the triangles are similar by S, S, S similarity. Now let's move to the last one, which is called side angle side similarity. What is side angle side similarity? The word is again self-explanatory. Side, one side upon side. All right, one angle equals another angle, and then another side upon another side. If we have that condition, then we can say both the triangles are similar using side angle side similarity. I hope it's pretty much clear, the types of similarities. Talking about one question, let's take one question and understand this so that there will be no confusion here. So for that, let me take two triangles. So yes, this is our first triangle, and talking about another triangle, let's say this is our second triangle. All right, and suppose I'm just taking one example here. So this is ABC, this is PQR. And basically, this is given 6, this is given 12, this is given 3, and this is given 6, and this is given 5, and this is given 10. All right. Yeah. So now we have to check whether both the triangles are similar or not. So just for this question, I'm going to make you understand with the help of, like I'm going to do a detailed solution for this. So how we should start? We can start like this, that in triangle ABC and triangle PQR. Basically, I did not want to take this example in this video because I wanted to make a separate video where I'll be solving at least 10 questions on congruent triangles and similar triangles, so that you will also get an idea how to solve these questions. I'm going to write down the steps, everything, so that you will understand properly. All right. So basically what I'm doing here, I'm just doing something which I badly wanted when I was in school. I wanted the detailed solution. I wanted to, understand the steps. So I know the feeling. That is why I'm sharing with you guys, and I want you to take all the benefits. All right. You guys are fortunate that you are having this opportunity, that you can see everything from the YouTube. We were not having this opportunity. So yeah. All right, let's move to the solution. So yes, in triangle ABC and triangle PQR, as I said, I'm going to make a separate video in which I'm going to cover 10 questions on similarities of the triangles and congruency of the triangles. But in this video, let's take this example only, and then I'm going to end this video. All right, so in triangle ABC and triangle PQR, we can absolutely see that if I take the ratio of AB upon PQ, which is 6 upon 12, which is half, if you simplify this. And if I take a BC upon QR, it's absolutely 5 upon 10, which is again 1 upon 2. And if I take the ratio of AC upon PR, which is 3 upon 6, which is again, if I simplify, it's 1 upon 2. So you can notice here that if I just take all the corresponding, the ratio of the corresponding sides, that means AB upon PQ, which is half, equals BC upon QR, which is again half, equals AC upon PR, which is again half only. So we can notice here that the corresponding sides are in the same proportion. Okay, we are having this condition. As soon as we will get this condition, we can write down. Therefore, triangle ABC is similar to triangle PQR. By which similarity? By which similarity? Very straightforward, by side, side, side similarity. That's the meaning. All right, that's the meaning of side, side, side. So yeah, I hope you have understood this. Now, I just want to tell you one thing, that I have not talked on this video, like in this video and my previous video also, which is this word, CPCT. I know you must be wondering that why am I not talking about this word? I'm going to talk about this word when I'm going to solve the questions in my next video, whenever I'll be making that next video, and I'll be explaining what is the CPCT. So right now I want, if you know the full form of the CPCT, let me know in the comment section. If I'll get the answer in the comment section, I will understand that, okay, this particular person has, watched my video till the end. So yes, I hope you have managed to watch the video till here. So thank you so much. This is for you. Thank you for supporting my channel. Thank you for watching my videos. I'm absolutely grateful to everyone. All right, so yes, this is what I wanted to basically cover in this particular video. I hope you understood the concept. I hope you understood now the difference between the congruent triangles and similar triangles. Now, as I said, in the next video, I'm going to make solve questions and answers on congruent triangles and similar triangles, which I'm going to do in the next video. So yes, if you like the video, if you understood everything what I explained, do like my video and don't forget to subscribe to the channel. Thank you so much. Keep loving, keep supporting, and see you soon, guys. Thank you.